In triangle ABC, draw line segment BE, which divides angle B into 60 degrees and 20 degrees. Now draw line segment CF, which divides angle C into 50 degrees and 30 degrees. Finally, draw line segment EF. Label angle BEF by the variable x. The problem is, solve for the value of x in this diagram. By way of history, this problem is known as Langley's adventitious angles. It's also known as the world's hardest easy geometry problem because it can be solved by elementary methods, but it is notoriously difficult to do so. Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for the solution. There are two main principles we'll use to solve this problem. The first is that in a triangle, the sum of all of its angles is equal to 180 degrees. If we have a triangle where we know 2 of the 3 of its angles, we can use this information to solve for the third angle because we know all 3 angles together sum up to be 180 degrees. The next principle is that in an isosceles triangle, we have 2 equal angles that are opposite 2 equal sides. If we have a triangle where we know there are 2 equal angles, we can conclude that the sides opposite those angles are equal to each other. Similarly, if all we know is that a triangle has 2 sides which are equal, we can then conclude that the angles opposite those sides are equal to each other. To solve this problem, we're going to create a series of isosceles triangles in order to get to the value of the angle x. And it all starts with a magical triangle that we're going to create right from the beginning. What we do is we draw angle BG, and we're going to do this so that angle CBG is equal to 20 degrees. So I'm going to relabel this diagram. That 60-degree angle we're going to divide into 20 degrees and 40 degrees, and these are the angles from before. Now, what can we say about this triangle? We know that 2 of its angles add up to 100 degrees. So the third angle in this triangle has to be equal to 80 degrees so that the sum of all of the angles equals 180 degrees. So this means angle CGB is equal to 80 degrees. Now, angle CGB is equal to 80 degrees, but also angle GCB is equal to 80 degrees. So we have an isosceles triangle where we have 2 equal angles. Therefore, the sides opposite those equal angles are equal to each other. We have BC equal to BG. Now we know angle CGB is equal to 80 degrees, so angle BGE we can figure out has to be equal to 100 degrees because a straight line always adds up to 180 degrees. So now let's consider the next triangle. Here we have triangle BGE, and we know that one of its angles is 100, another angle is 40. Since all of the angles in the triangle have to add up to 180 degrees, that means the final angle in this triangle, BEG, must be equal to 40 degrees. And once again, we have 2 angles which are equal to each other. Therefore, the sides opposite these angles must be equal to each other. So we can conclude that sides BG and GE must be equal to each other. Now let's consider another triangle. We know that 2 of its angles are 50 degrees and the other angle is 80 degrees. So we can solve for the third angle knowing that all of the angles sum up to 180 degrees. So we can figure out that the last angle, BFC, is equal to 50 degrees. Once again, we have another isosceles triangle. Therefore, the 2 sides that are opposite those angles must be equal to each other. So BC must be equal to BF. Where do we go from here? We're going to draw another triangle that's in this figure. We're going to have to connect points G and F. So we'll consider this triangle BFG. What can we say about this triangle? Well, sides BG and GF are equal to each other. And we know that angle GBF is equal to 60 degrees. So since all three angles sum up to 180 degrees, we can figure out the other two angles must be equal to each other, and they're the remainder of 180 minus 60. So since BG is equal to BF, we know the opposite angles of those must be equal to each other, and they must be 1/2 of what's remaining from 180 minus 60. So we can figure out that these two angles must be equal to 60 degrees. So what does that mean? We have an equilateral triangle because all three angles are equal to 60 degrees, and that means all of its sides must be equal to each other. So let me just draw this in. We have GF. This GF must be equal to the other two sides of the triangle because we know all of the angles are equal to 60 degrees. We divided this 100-degree angle into 60 degrees, and what's left over is 40 degrees. So now we've done all this work and we're almost there. So we're just going to need to consider one more triangle. I'm going to remove information that we don't need for this final calculation. This way we can focus on the triangle that we do want to consider, where we can figure out the value of x. So in this final triangle here, we know that all of the angles sum up to 180 degrees. But there's also something else we know about the triangle, is that two of its sides, GE and GF, are equal to each other. So this is another isosceles triangle, and we want to remove one of the angles, which is 40. So the two angles which are remaining, GFE and GEF, must be equal to whatever 1/2 of 180 minus 40 is. So we have 140 divided by 2, which is 70 degrees. So one of the angles is 70 degrees. The other angle we know is 40 degrees plus x. So we can conclude the other angle in this triangle must also be equal to 70 degrees. This means 40 plus x is equal to 70, which then means x is equal to 30 degrees. And that's the value of x. So we have 30 degrees as the value of x. I'm going to go back to original figure, and what we figured out is that this value of x is equal to 30 degrees.